Hello and welcome. My name is Pradol Sai. I'm a student of Software College in semester third. I'm making this video for my individual project, which is milk quality classification or analysis. So, in this project, we are going to see about the quality of milk. I guess milk is one of the most consumed daily product in the whole world. So the quality may differ from different phases, high, medium, or low, and it is very important for dairy dairy factories or like production area to look after the quality of the milk before selling. If the quality is low, then the dairy might be affected, or the health of person might be affected, or the dairy might be affected financially. So without further ado, let's go and look at the code. So I guess before going towards the code, I think it's really difficult. So the problem statement is that it is really difficult for really difficult, and it is expensive for milk to be analyzed in lab. So I've created this system, which is milk quality analysis or classification. So I've used Tkinter for the uh, Python, and Tkinter for the graphics interface. Okay, I've used NumPy and Pandas for data pre-processing, data cleaning, and everything else. So when the program starts, it automatically loads. It automatically tries to load a pretend model called milk model.pkl, which is encoded in binary language. Which, if I open this, it might get corrupted. So the file exists of if the file exists, then the model, the scalar, the label encoder, and performance matrices are loaded instantly. If it does not exist, the system prompts to the user to retrain using a CSV dataset. So let's move to the data pre-processing part. So uh, the data is loaded to uh, data set is loaded using pandas. The column names are cleaned, and uh, the column names are cleaned, and it removes the missing value, ensures that the grade column is exists, and remove duplicate rows and everything. So all the pre-processing part is done in this part, right? So after this after this, model training. Okay, where is the model training part? So okay, so for this project, I've used random forest classifier, random forest model, which is obviously classification model, and I've used gradient boosting. Random forest improves the stability and reduces variance. Let me give you a short description about random forest, which is like you've combined multiple decision trees together in one in a single model. Then it creates forest. So that's a random forest model, and a gradient boost improves accuracy by learning from the previous errors, right? So to ensure reliability, I've used the train test 80-20 train test split, and I've used 10 fold cross validation. and to detect overfitting. Okay, let me just, yeah, sorry, I had to stop. But to detect the overfitting, uh, uh, I've took out the train accuracy, test accuracy, and cross validation and accuracy gap. If the gap between training and testing accuracy is large, then the system warns about overfitting. It comes by tick, else it is fine, right? So the model, after training the model, it is automatically saved as milk underscore model dot pkl. So the next time we launch it, it opens directly the pkl file. It's simpler. Now the user interface. I don't want to say much about this user interface, but let me show you by running the code. Okay. So this is our user interface, where we've got sample parameters, where we separate by pH value. I'm going to show you a data set a little after this, after a little while. So this is pH value, taste, which is in binary, either it's good or bad. Fat is present or absent. Color ranges from 240 to 255, like the color of the milk. Is it white or white yellowish? According to that, the temperature, which is 35 to 45, is the freshest one, or else it may not be fresh. Order, is it good or bad? Or turbidity, is it high or low? So let's let's put this one, let's put this 6.7, and let's classify the milk quality. So the quality gives here, it's high 83%, high low 3%, and medium 14%. This is how it's classified. So the maximum result says high. Overfitting is not detected. The test accuracy is 84.62%. Train accuracy is 100%. Cross validation is 91.83%. And this is the confusion matrix. This is the confusion matrix. And here are the features, right? And this is it. Um, yep. And this is the gap. This is the gap, 15.38%. If it is more than, yeah, the model is overfitted, right? So let me show you the data set. This is the data set which we are using. We have used pH value of the milk, temperature, taste, order, fat, turbidity, color, and this is the grade, which is so this is the data we have cleaned, and we've performed the machine learning. Uh, we have uh, like pre-processed the data, and it's set it in machine learning algorithm. Okay, thank you. This is it for the video, guys.